Good morning, thank you. So I now know why I'm qualified to do this talk. It's not that I know anything about ISO 15189, it's the fact that I'm called David, along with the previous two speakers. So, let's see if I can find a talk for you. So, here we go. Disclaimer. It's a good start, isn't it? You might realise why I put this disclaimer here, because most of what I'm going to tell you is factual. Some of the content is subjective and is formed from my personal opinion, and some of you who know me from the past know that sometimes my personal opinion is not really politically correct. However, it is a true reflection of an inspection of our service that took place in October 2014. Remember that date, October 2014, so it's some while ago, and I might have forgotten one or two things. However, it is intended to act as a snapshot of such an inspection, and it may be what you might expect to see if you would have one. So UCAS, the United Kingdom Accreditation Service, it's recognised by government, and it's there to assess and declare the competence of organisations against internationally recognised standards. And of course those standards are ISO 15189 if you live in the north, or ISO 15189 as we tend to use in the south. UCAS is independent from government, it's subject to peer review, and they have a duty to act in the public interest. So maybe this is what you think of UCAS, and certainly there's some trepidation when people come to their inspections. This is the document that we're talking about, and I'm not sure whether I'm allowed to show you this because this document has lots and lots of copyrights on it. It has disclaimers all over it. It's 52 pages in its entirety. Anyway, I've taken the chance and I've shown you the document. In our laboratory, would you believe, we had one copy, it was registered to the quality officer, and you were not allowed to photocopy it, and if you wanted to go and see it, it was locked in a room. Now to me, if government were to make laws in this land and not tell us what they were, how will we obey them? So this document should be released to everybody. You know, the most important people that should read this document are your most junior staff. They're the ones at the bench, they're the ones that are putting it into practice. They need to read this, so it doesn't need to be locked away in a cupboard. Okay, I'm really frightened of that copyright, so we're no longer looking at the document, but these are the contents. And really, the first three things just outline what the document's going to do. It talks about the terms and definitions that are used within the document. And then we've got sections 4, which are management requirements, and they're listed, as you can see here. I'm not going to read them out, but these are just the sections, and within each of these sections, there's another 4.1, 0.2, 0.3, etc., etc. And they're just statements. And then there are some additional notes that might give you guidance as to how to achieve these objectives. And this is the second part of it, the technical requirements. So most of you are CPA accredited and will know the sort of things that we need to achieve for pre-examination, examination, post-examination processes, reporting results. So most of this is relatively familiar. And this is the flow diagram. I haven't got a pointer, but you'll see as a user they make a request, we go through the examination processes, and then we report a result. But in the background, there has to be all of these other processes that regulate that examination process. And this is about trying to achieve quality and validity of those results. And you'll see the familiar things like evaluation and continual improvement. So we need to reflect on what we do. We need to audit. We need to have a quality management system that has these things stated in it so that they are performed. Resource management, there are some new additions in resource management about equipment and reagents, and we'll go into some of these. So, UCAS, meeting the international standard means that the laboratory meets the technical competence requirements and the managerial system requirements to consistently deliver technically valid results. And really it comes down to this. Your laboratory needs to be able to produce consistently valid results that are fit for purpose. And if you remember those few words, whenever you're performing your testing, or wherever you're thinking about setting up a new test, you won't be far away from the UCAS standards. So before you visit, what do you need to do? Well, it's a bit of an understatement. You need to read the document. Not so easy if it's locked in a cupboard. Review your quality manual. Perform a gap analysis. So the gap analysis is the difference between the new standards and those of the old CPA standards. And you need to identify the things that you don't have in place. And then you need to provide objective evidence that you've achieved the standard. And you need to remember, where does it say what you do? Why is it done that way? Do staff know what should be done and why? Training and competence. Where is the evidence that this has been implemented? Is the evidence objective? So will people believe you? What does the evidence tell you, and does it work? So if we look at the standards against CPA, we can see we've got some modifications and some new ones. Evaluation and risk management, purchasing equipment reagent records, laboratory director, clinical staff competence. That's interesting. But they now have specific roles they have to achieve. Staff competence, information management, and we go on. So let's look at these. Evaluation and risk management emphasise the need for regular reflection. Yeah, mostly we do that, but it has to be documented. You have to have evidence that you are doing this reflection. So you have to be conducting your audits. You have to review your audits. You have to hold your annual management review. These are all parts of the process. Evaluate the work process for impact and potential failures to reduce the risk. So you have to look, can I produce that test every single day when it's requested? And all of the things that are involved in producing that test. So that comes down to suppliers, it comes down to all sorts of processes related to your analyzers, related to your reagents, to your staff, to your institution, to your premises, etc. You have to look at the whole thing in a holistic approach. Establish key performance indicators that are regularly reviewed. So you have to do self-monitoring. Useful if you can get external organisations to come in and review your process. So it may be that you get regulatory bodies coming in, MHRA, people like that come in and give you a review. It may be suppliers. So you may provide a service to somebody and they come back and review your organisation. So those are all useful things that you can use as evidence. Purchasing equipment reagent records. If you buy a piece of equipment, you need to have acceptance criteria. You need to evaluate that piece of equipment. You need to retain all of the evidence that it does what it says on the packet. You need to constantly monitor the performance of those. And if possible, you can collaborate with other departments. So this is very onerous. If you take a new piece of equipment, you buy a new flow cytometer, how are you going to validate that that flow cytometer works? Some of the acceptance criteria have already been published by the companies, but by other people. And you can use that as part of the evidence. So you would not necessarily have to do a full verification. You could just verify against those standards. Reagents and consumables. So this is quite considerably expanded. You need to have records of all of your reagents when they come in, how you store them. So you need all of your records to the storage for those reagents. acceptance testing. So how do you know that that CD19 will pick up B cells? You need to verify that it does, particularly if you're using outside of the manufacturer's instructions. Records, identity, condition, instruction, performance verification. You need to keep documentary evidence of all of that and have it readily available. The laboratory director and clinical staff competence. So now they have very listed responsibilities and they're going to be held to them. As we've heard in the earlier talks about the professional liability for these people, whereas before they just say, oh, well, the lab manager looks after that side of things. It's now the responsibility of the laboratory director to make sure that these processes are taking place. You need to have ongoing competency assessment for all of those individuals. I think that sometimes the clinical staff dip in and dip out of laboratory medicine. Not necessarily always qualified. Well, I'm a consultant, I've passed my FRC path, I'm qualified to do it. Acceptance criteria for performance of all of your tests, records of qualifications, experience and training. So you now need lists of everybody that's performing tests, what their qualification, etc. And they are responsible for making sure that internal audit is appropriate for the laboratory environment. Staff competence, objective evidence. So not say, oh, well, I think they belong to that scheme. They actually need the pieces of paper. I did this scheme, this was the result, this is my reflection on it. And it does specify that you need lists. Ongoing assessment against predefined criteria. So you need to set out the criteria which you want your staff to work to, and then assess against that. Continuing education and proof of effectiveness of that. So people go to meetings, staff go to meetings, they need reflecting when they come back to prove that that is being effective and they brought something back to the lab. And personnel records to include accidents, work experience, everything like that. But I have to say that the emphasis of the ISO 15189 is not around health and safety, and I think probably that's one of the differences between this and CPA. So CPA talked about health and safety quite considerably. That's not part of 15189. Service agreements. So most of us understand, or all of us understand, service level agreements with providers. But this goes one step further. It's now saying that each individual request should be considered as a service agreement. The agreement should specify the information needed on the request to ensure appropriate examination result interpretation. So you receive a request card, it should tell you what the investigation is, and it should tell you all of the clinical details. My guess is that quite a considerable number of investigations don't have that. Following conditions should be met. Requirements of the customers, users, providers. So that's along the lines of CPA. But you do need the evidence. There is no longer a meeting. So when you are inspected, there is no longer a meeting with your end users. So that was certainly a difference from CPA. Information management. This now takes into account providers of LIS, HIS, etc. You need to treat this as a major part of your equipment. And you need to think about contingency plans if it goes down. And particularly now that these systems are often held remotely, you need to be certain that your provider meets all of the requirements for your specification. I can think of an instance where our hospital, a number of years ago, was running its HIS system off-site. And there was a big explosion down towards London. Buntsfield, one of the oil containers, blew up. I think it was a gas container. And the backup system for our hospital was in the building next door to it. We ran the hospital on the pathology system for a week because there was no contingency plan for that to go down. Traceability. You need traceability for virtually everything that's coming into the lab, whether it be equipment, reagents. And you need to be able to verify at defined intervals. So you need to check each time it comes in, you need to check that you do have full traceability for that. And it may be such that there is a recall on an antibody. You need to be able to identify exactly when that if you had that antibody, when it came into service, on what patients you used it on. That's quite extensive traceability. Records and metrological traceability of calibration standards. So this is a little bit of a thorn, but take the example that your pipettes. So the accurate calibration of a pipette is essential for you to perform and produce a valid result. And most labs, some labs, will not do that themselves. They will get some commercial organisation to come in and do it. Okay, that's fine. They give you a certificate and say it's calibrated. But you need to know the full metrological traceability. So you need to know what that company is calibrating whatever they've tested your pipettes with. So what is the primary source? And they need to have all of that. You need to have that documentation from them. Provenance of reference materials, where they come from, and are they a true representation? And where traceability is not possible relevant, other means of providing confidence in the results are required. So that leaves it up to you. Now we're going to talk about validation, and that's confirmation through provision of objective evidence. See that word again, objective, it's not subjective. But the requirements of a specific intended use or application have been fulfilled. And again, you need to define acceptance criteria. It needs to be a documented procedure. Critical evaluation of manufacturer's validation, including traceability, as we've just talked about. Suitable for use within the lab for user demographics. Validation is supplemented where necessary. So if you think the validation is inadequate, you need to do something about it. The onus is on you doing these things. Changes to any of your methodology will have an impact on your validation, and you need to retest. So David talked earlier about Euroflow. That is probably the single test that is most validated within flow cytometry. However, if you use your CD19 on a different fluorochrome, you need to revalidate everything. That completely throws the whole assay out. If you use a different lysing reagent, the whole assay is no longer validated. And then you need to have mechanisms for authorization. So people responsible to sign off that validation. Verification. Confirmation through provision of objective evidence. It's there again, objective evidence that specified requirements have been fulfilled. Documented procedure to verify competence. Can manufacturer's specifications be met? So that's part of your verifications it can be. Have representative staff been involved? Again, authorization signed off by competent personnel. Uncertainty. Requirements cover examinations reporting measured quantity values and those that include a measurement step. So if you're performing a complex panel, you're maybe not issuing a measured quantity value, you're issuing an interpretive report. And maybe that doesn't, so therefore it doesn't require you to conform. But certainly if you're enumerating anything, CD34, FMH, where you're issuing a result, you need to be able to state your uncertainty that that result, or your certainty that that result is a true value. Performance requirements for each measurement procedure need to be defined. So you need to state what your performance requirement is, and you need to review regularly. Uncertainty estimates to be readily available. You don't have to produce those with every single report, but if somebody requests what your uncertainty of measurement is, you should be able to produce it. EQA, IQC, proficiency testing and inter-laboratory comparisons are critical in demonstrating competence. I think probably growing up through CPA, that's probably a given. Documented procedure, responsibilities and participation. You have to have evidence of all of this. And you have to have acceptance criteria for the scheme and acceptance criteria for the results. Internal quality control, ongoing monitoring by IQC for your tests is an absolute requisite. It needs to be suitably robust. So, does it serve the purpose? Does it give you a true measure? And could you use that for measurement of your uncertainty? And again, documented procedures with responsibilities. Staff suggestions, communication processes need to be effective. Staff to be encouraged to make suggestions to improve. You get the whip back, tell me what we're doing wrong. It needs to be evaluated, implemented as appropriate, with feedback. So now you've got a process where staff can make suggestions, they should be documented, there should be a response, feedback as to whether that's implemented, if not, why it's not implemented. And you need to retain records. So you need regular meetings with your staff and reflection. So that was just a quick review of the differences between, or some of the differences between CPA and the new ISO 15189. And you've read the document, you found it sitting in the cupboard, you've got it out, dusted off the dust, had a look, and you're about ready to go for your accreditation visit. And the first thing that you need to fill out is your AC4 form. And this is for labs that are transitioning between CPA accreditation and to ISO 15189. And this is the form as it appears. And towards the bottom here you can see this is what we entered for hemato-oncology. Leukemia diagnosis by screening against leukemia monoclonal antibody panels, CD34 enumeration, immunological platelet counts using a BD FACScan total flow cytometer. Leukemia diagnosis by examination of bone marrow and blood film morphology. Leukemia diagnosis by immunofluorescence and cytochemistry. That summed up the flow lab. Nice and succinct, we thought that did the job quite well. And we put in a couple of SOPs as an example. Okay, so that's what we did at the time. And we were advised by our quality manager at the time, that's what was needed. And they review that, UCAS review it, and they'll come back with a visit plan. And this was a copy of our visit plan. I've taken some of the names out, but not all of them. If you work for UCAS, well, you can be named. And they ask for some additional information. So you have to provide them with an up-to-date quality manual, your management review minutes, SOPs relating to methods due to be witnessed, and we'll look at those in a minute, summaries of your EQA performance, internal audit program for that current year, and an example audit, that's what we had to provide, validation and verification reports associated with the tests to be witnessed, updated gap analysis. So they require you to do that gap analysis and document any areas where you believe that you don't meet the criteria. And then, of course, you've had to have satisfied the criteria. So all of those documents go off. And this was our visit plan, and I kindly removed all of those people that came to inspect us as technical assessor experts. The assessment manager and lead assessor is usually the same person, and that's your UCAS employee. And you'll see there that you do have observers. So you might have technical experts, but they have a shadow. And I think they're probably as frightened as that shadow as you are of them. Because they sit there and document everything and they say, no, you can't say that. You didn't ask this, you didn't ask that. If you ever speak to an assessor, I think it's quite a terrifying experience. So this visit plan gives you a guide to the assessment meeting dates, the times, when everybody's going to be there, what they're going to be inspecting. So it's a fairly well documented list. And from your AC4 form, you will realise that actually everything you put on there is what they've got to, or only what you put on there is what they've got to go on. So you can see that we had a very brief AC4 form. It was succinct. But of course, when they come to assess us, they can only assess us on the basis of what you've written there. So you can virtually see at the bottom of here, and I could do with the pointer, at the bottom of this table you can see, there it is, it's almost cut and pasted in. Leukemia diagnosis by screening against leukemia monoclonal antibodies, CD34 enumeration, immunological platelet count, using a BD FAT scanner. It's almost word for word. So that's what we were inspected on. But this is what you need to be aware of. You need to think about, for those tests, you need to have evidence that you can cover all the requirements as listed here. And that includes accommodation, equipment, reagents, the pre-examination, the examination, post-examination, everybody that's involved in it, all of their competencies and their roles. This might include job descriptions, etc. Evidence that people that are doing reporting and writing clinical advice, clinical interpretation, whether they are competent to do that. All of your quality assurance, internal quality assurance and external quality assurance records, all available for review. So the visit, what to expect? Well, you've done your homework. So now maybe that frightening tiger is not quite such a frightening tiger, but still maybe you don't quite trust them. The opening meeting, the lead assessor will focus on the gap analysis, the quality management systems, including support activities, and coordinate all the technical experts. But mostly the people that you will see will be the technical experts. And they're allocated specific tasks, covering the process from sample receipt to reporting, post-examination. They may use reporting forms, but they don't use checklists. So in the old CPA, we used to have horizontal audits, checklists, vertical audit checklists. That seems to have all gone. They'll assess the aspects still using similar techniques, but they won't go through that check thing anymore. So it's up to you to make sure that you can satisfy the requirements. And it's evidence-based. So if you say something, they'll turn around and say, okay, show me. So you'll say, this is all the validation, this reagent's been fully validated. Okay, where's the data? You need to be able to put your finger on it straight away. Evidence-based approach, focused discussions on key differences such as traceability, validation. Those are the new things that we really need to get our minds around. And you need to demonstrate how you meet the requirements. They're not going to tell you that it meets the requirements. The assessment will focus on the outcomes, and it will seek to demonstrate that the accreditation can be granted, i.e. the production of valid results. That's what the accreditation is about. Objective statements will be used to record any potential non-conformities of opportunities or opportunities for improvement. And the assessor will ensure that the statements are factual and agreed by the lab. So we had our visit on the 23rd of October, and this was issued on the 28th, and this is a summary of the non-compliances that we receive within the flow lab. And I'm just going to go through each one of these non-compliances and how we addressed or how we tried to address them as an example of how we did it. So if we look at the first one, the in-use stock monoclonal antibodies has a number of expired reagents. These are no longer used, but have not been discarded. So we're working in quite a big laboratory. And these are our fridges. So the one on the left is the one that's in use. And I think there's something like about 130 antibody vials in those trays. And we didn't have a process, we didn't have a stated process of regularly monitoring whether those reagents were in date or out of date. Now clearly the ones that you use constantly, and we churn through those at a massive rate, they're always in date. Most antibodies come on, they've got at least a year or 18 months expiry on them, so it was not a problem to us. However, on the right, you'll see that there are some hidden boxes, and your inspector will delve through all of those. And that was our problem. So in order to comply with that, we changed our SOP and made a statement, general housekeeping. A general antibody stock check will be formed monthly, and expired reagents will be logged routine use. Quite simple. Our second one, small volumes of residual monoclonal antibody are retained in a box labelled dregs. You've got one as well. So we make up large antibody cocktails, and invariably you don't use all of those at the same rate. So you end up making up a cocktail, there's not enough in one bottle, so you start a new one. Because it's usually of a different batch, you don't mix them. And this was what was in our container. There was something in the order of 100 vials in there. And I did a very brief calculation that if there was between 50 and 100 microlitres of antibody in there, there was around about £2,000 worth in that lot. And we never checked this. So of course when our inspector came along, wow, he loves that. So to comply here, again, change the SOP and a statement just to say that we were going to check the dregs box. Okay, the in-house produced cocktails of monoclonal antibodies for leukemia phenotyping do not have expiry dates. Of course, all the individual components had expiry dates, but we changed the formulation when we mixed them all together. And our inspector decided that we needed to have an expiry date on the vial. And you can see, this is our check sheet before we went into the inspection, and you can see we logged most things. So we logged the batch number of all the reagents in there. We had a cocktail prepared by, and that's prepared by 2 scientists. And then we stick all the patient labels that we tested with that cocktail onto the sheet, and then we keep that sheet forevermore. And that's our traceability for that reagent. So in order to comply with this, we just added an expiry date, and we just normally took 4 weeks. Generally speaking, our cocktails last about a week. IQC for CD34 assay monitored as a percentage rather than absolute count. We needed to revise the IQC monitoring charts to monitor absolute counts. We were just taking the percentage. And again, quick change in your SOP said the CD34 check control material, the values will be logged and monitored in the phenotyping QC folder on the shared network, available to everybody. We had a slight disagreement about this. The CD34 count protocol requires 100,000 CD45 events to be counted. This is not in keeping with the published methodology and has not been validated. We use this is a table from the late Terry Hoy in one of his published monographs, and it talks about how many the numbers of events that you need to count in order to get a statistically viable answer. And we used 100,000 CD45 events because if you took a peripheral blood stem cell harvest that had a white count of 10, then that was the equivalent of 10,000 cells per microlitre. If your CD34 positive value is 0.1% in that sample, we would have counted 100 CD34 events in 100,000 CD45 positive events. And that would have given us a CV around about 10%. That was suitable to us because it was clinically relevant for the test that we were performing. That's what people wanted to know, because the threshold for collecting a peripheral blood stem cell harvest was 10 CD34 cells per microlitre. So at that level at which they were going to harvest, we had a coefficient of variation of 10%. So that was why we were doing it like that. However, you need to jump through the hoops. So we changed our protocol and said that we were going to ensure a minimum of 100 CD34 positive events have been collected. If it is less than 100, reacquire the tube and record the additional events and pen them to the file overwrite. So in fact what we do is still count 100,000 CD45 events. If we haven't got enough 100,000 CD45 events, if we haven't got 100, we just add some more to it. The benefits, and as a quality improvement, if we are trying to improve our results, when we actually come to do the harvest, where there's many more CD34 events, we find that we can reduce our coefficient of variation in the result quite considerably. So sometimes just stopping at 100,000 events is not the answer. I'm going to move on quite rapidly here. The Hodge laboratory has determined uncertainty and measured quantity values. We had a statement about our uncertainty of measurement phenotyping. And because we couldn't do all of these QC values, this was no longer valid. So we had to add that to the document. There is no QC process for immunological platelet counts. And we made a statement as to why we could do no IQC for immunological platelets. And I should have had a result chart there. But essentially, we felt there was no material in which we could do it. Peripheral blood, if we take normal peripheral blood, the reason we were doing immunological platelet counts is because they are often different from what you produce on the normal analyzers. So just taking a full blood count from the routine lab and analysing, we would frequently get a different result to it. Therefore, it was useless as IQC. So that was our responses, and this is what came back from responses. And you can see that 3 of the responses were still outstanding, and we had to complete a second round. This is what we introduced for the CD34 QC. We just literally, that was quite easy. We monitored it on graphs and we report it as an absolute value. And you'll notice this. That was the change to the SOP. The SOP originally said we would report the CD34 check values, not the absolute values. So we changed it to absolute values and that passed. The next one, no QC process for the immunological platelet count, and we made a statement along the lines that it was invalid to do it on a full blood count. And that was the data that we supplied, and we show that we've got really nice conformity within a sample, reproducibility in the sample at sample 7 there. But you can see that some of them are 48% different, 41% difference. That's why you can't use a standard full blood count as QC material. Following round 2, this is what came back. Note that. So 2 non-compliances. However, when you look at the sheet, there was only 1, and it was still around the immunological platelet count. So you can see there for 005, not cleared. We had to go 1 more round, and that's what we did. And we produced a graph, and that is from the fixed material, from the full blood count material that's supplied by the National Quality Assurance Scheme. We charted that, and that allowed us to calculate an uncertainty in measurement. And that's where we finished up. I do not have any outstanding actions relating to this assessment. And we were cleared. So where are we now? We've got CPA accreditation. ISO accreditation is pending. So that's the message I got from the quality manager. And I said, well, surely we did that a couple of, We signed off in April, it's now June. And that was his response to my email saying, why aren't we accredited? We are waiting for the decision maker at UCAS to make the offer. Everything we needed to do has been done. Patience. Yeah, right. And we're now in the form of filling out an AC6 form, which is what you apply for when you go for full ISO accreditation. And you can see we've learnt the lesson, because now we're listing every single test, all the SOPs. It's much, much more informed. So in summary, UCAS website has lots of helpful info. Read ISO 15189, take it to bed with you. Perform your gap analysis, complete a detailed AC4 or AC6 form, because that helps you. Ensure you cover all the new areas. Collate objective evidence and know where it is. Attention to detail, don't panic, because that changes to that, and hopefully you see your inspector as this. Acknowledgements: Brian Warner, my operations manager, and who is currently a UCAS inspector. 2 quality officers, Helen Busby and Angus Gibbman. Stephen McDonald, that did all our work on uncertainty and measurement. And the people who work in the flow lab that face the inspector. Thank you.
Thank you, David. I suppose the one thing I draw from that was that I get the impression that the assessors were pretty switched on to immunophenotyping.
Oh yeah, very much so.
Which is encouraging. But given the time and energy put into providing validation and verification data, how much time can they actually physically spend in looking at that? Because it would be a substantial amount of work, wouldn't it? And documentation.
But you have to do that as your homework beforehand. And it's literally, where is it? Okay, they didn't inspect it in great detail, but they wanted to see that you had the files, you had the documentation. Yeah, it takes you weeks and weeks and weeks to get that documentation together.
Okay, we're running a little over, so any quick questions for David? How many people have actually got 15189 accreditation already? Oh, that's good. Yeah. Well done. Everybody else striving. Okay, quick questions? Mark.
One of the most important areas in flow cytometry, but there is a lot of subjectivity and variability involved between laboratories. How do inspectors make sure that meaningful inter-laboratory comparison is made? What standard they use against which they make a decision of fail or pass for a particular laboratory on this particular issue?
I think you just need to produce evidence that when you formulated your panel, that you have got full verification data of the individual antibodies and that you've fully validated it when you put it all together. Now, if you are copying something such as Euroflow, you need to use everything in that system. So it's not just that you've got a CD79A, a CD3. David went in earlier about, do you carry these antibodies? It's not do you carry these antibodies, it's do you carry these antibodies? Are you using them from the same manufacturer? Are they on the same fluorochrome? And do you use them in a process that uses the same reagents, the same buffer, the same lysine reagent? You take it as a package. And I think that the data that David showed earlier was just the tip of the iceberg, because I suspect there probably was only one laboratory using that system in its entirety. Therefore, those results were perfectly verified and validated against Euroflow.
Okay, Joe, I'll take one more question from Mark at the back there. Okay, put your hand up, Mark.
Hi, Mark Simpson from Sheffield Children's.
Shall I just shout?
Yeah, okay.
I've got a loud voice. We went through the process a year last April. It was bruising.
Yeah.
Is the adjective I but we were re-inspected last July. I would urge anybody to really, really take this very seriously. If there's anything that you differ from in your processes, it will be found, and you will have to validate and verify everything, which hopefully we actually managed to do last July. I'm still waiting for sign-off from UCAS.
Yeah, the decision maker.
So we're in limbo.
Yeah.
But please do not take this lightly. It is probably the most serious inspection you will have in your departments, in your careers, I think.
Yeah.
Thank you
But it
for
can
that.
help us in the end.
It will help. And interestingly, in France, the government are decreeing that all the laboratories have to be accredited to ISO 15189. And they've stipulated, I think, by 2017, if you're not testing.
It's interesting that what you say about the sign-off, both of you. I mean, one of the big criticisms about CPA was the delay in getting, that sign-off back to the labs, and UCAS seemed to have got worse. Paul, one quick one.
Just one comment on flows, certainly UCAS. I mean, it's commonly an area that hasn't been assessed that well under the CPA. And certainly for our lab, we've not been assessed in 4 cycles of CPA. And the assessment for the first time, it's actually looked at top to bottom, all tests, by somebody who actually knew what flow was about. So I think that's the level of assessment you're at now. And I think, some of these more niche specialist areas like flow, toxicology, neonatal screening and biochemistry are coming out as being issues for UCAS because they haven't been assessed that well previously.
Okay, thank you.